We have a normal distribution example here, exam 1 style, okay? So you would do this by hand. We've got a normally distributed variable x which has a mean of 30 and a standard deviation of 7. Now, if z is the standard normal variable where the probability that z is from minus infinity to plus 1 inclusive is 0.84, we have to firstly find the probability that x is less than 23. Secondly, we have to find the probability that x lies between 23 and 30. And lastly, we have to find the probability that x is greater than 37 given that x is greater than 23. Okay? Now this is where you have to draw a diagram, firstly to understand what's going on, and secondly to gain 2 marks in a 2-mark question, because if you just come up with the answer in a 2-mark question you can only be awarded 1 mark out of 2. Tragic but true. Now this question would be about the right strength for exam 1, so we've given it the amber light. Let's go guys, part A. Find the probability that x is less than 23. Okay, here comes the diagram. Now they told us up here that the probability that z, the standard normal variable which we know has a mean of 0 and a standard deviation of 1, we know that if the probability that z lies between minus infinity and plus 1 is 0.84, we can use this information to our advantage. Here is Mr. Z, there he is. Now we know that the probability that z lies from the left-hand end up here, from minus infinity up to and including plus 1, is 0.84. Now guys, we also know that the probability up to the hump here, the top of the bell curve, from the left-hand side from minus infinity to that point, would be what? It would be a half, and therefore that means that this little bit here, this little bit from the centre point to this bit here where z is 1 would be 0.34, and that basically is the key bit of information that we need, because that means therefore the probability that x now would lie from 1 standard deviation to the left of the mean up to and including the mean, that is from 23 to 30, right, which would be the same analogous situation where z would go from minus 1 up to 0, symmetrical to this situation we've got here. That probability would be the same as this probability over here, which would be 0.34, okay? So, if we want the probability that x is less than 23, we want this bit in here. We want that bit in there, but that's easy to work out because it will just simply be a half minus 0.34, which is 0.16, okay? So there's your answer. The probability that x is less than 23 would be 0.16. Now, do you see how easy it makes it when you draw a diagram? I can't recommend them highly enough, particularly if you're a little bit stressed in an exam setting. You need a diagram, and also to guarantee that you're going to get all the marks if it's a 2-mark question. Part B, guys, we want the probability that x lies between 23 and 30. Well, that's very easy. We've already worked that out, really, in Part A, haven't we? We know that that blue hatched bit there, which is what we're talking about, is going to be 0.34. So there is our answer. As simple as that. This is really easy stuff, this normal distribution stuff, in my mind. As long as you get a handle on it and just get a bit of practice, look, it's just the easiest mark on the paper, really. Now, in Part C, we've got to find the probability that x is greater than 37, given that we know that x is greater than 23. Now, let's use our multiplication formula for probability to work out what that really means. And that's what it means. It's the probability that x is greater than 37 and x is greater than 23 over the probability that x is greater than 23. Now, as far as this numerator is concerned here, guys, can you work that out? This is the stricter condition here, which covers both of them. So therefore it really means that x has got to be greater than 37. Because if x is greater than 37, it automatically means that it has to be greater than 23. But if you take it on the other hand, if x is greater than 23, it doesn't necessarily mean that x would be greater than 37. Now, if that's confusing, draw a number line, just like I'm doing here. See, this top line here represents x being greater than 23, and the bottom line here represents when x is greater than 37. and the intersecting bit is the overlapping bit on the number line. And the overlapping bit is where x is greater than 37. You see? So if you get confused with this stuff, maybe just draw yourself a little number line, and it'll become crystal clear to you. So we've got the probability of x being greater than 37 now over the same denominator as we had on the line above. Now, in order to work out what these mean in reality, we need our very instructive little diagrams. Now, on the previous screen, we worked out that the probability of x going from the mean to 1 standard deviation from the mean, that was 0.34, okay? So therefore, it follows that to go from 1 standard deviation to the left of the mean to 1 standard deviation to the right of the mean, the probability is going to be 2 times 0.34 or 0.68. And therefore it further follows that the probability in these two tails here combined will be 0.32. And therefore each of them in turn, because they're symmetrical, this whole thing is symmetrical about the mean, therefore each of these tails in turn will have a probability of 0.16 each. Okay? Now the reason I went to all that trouble is because I want to get the probability that x is going to be greater than 37, which is now crystal clear to us, it's 0.16. Now, for the denominator, let's draw another little picture. It follows, guys, that if this probability in here from 23 to 30, that is from 1 standard deviation to the left of the mean to the mean, is going to be 0.34, then the probability from that point onwards, right up to the, as far as you can go to the right, will be 0.84, because the right-hand half from the hump at the mean will be 0.5. Okay, so that's a combined probability from 23 to the right, e.g. x is greater than 23 will be 0.84, and that's our denominator. So now we're home and hosed, guys. We've got 0.16 over 0.84. If you multiply top and bottom by 100, you'll get 16 over 84, and if you divide through by 4, you'll get 4 over 21, which is our answer. Mighty fine. So there you go. This stuff is not rocket science. If you just keep a clear head and draw yourself some diagrams, you can work it out, no trouble at all.